So this is going to be a short tutorial on how to do an area of a complex figure geo-inquiry in mathematics. It starts out with a view of Lake Ontario, and if you're not there, you can hit this little bookmark. But if you just walk through the activity guide with me, the first thing it talks about is engaging, and how do you find the area of a complex figure, and you can talk with your students about what kind of shapes could you use to try to fill in parts of Lake Ontario. You'd find the area of each of those shapes and add them up and get an estimate for what the area of the entire lake would be. So hopefully students will start rattling off things like rectangles, squares, triangles, and trapezoids. Then we get into the explore part of this activity, and it says how do you find the approximate area of a complex figure. And over here on the left hand side there's a content button, and you'll see that we've made rectangles, squares, triangles, trapezoids that will slowly start to fill this entire surface area up. And we'll work through finding the area of each of them and adding them up and getting a total surface area if possible. So here goes the first one. We have a rectangle layer. Find the area of a rectangle. Hopefully you can talk with your students and talk about it. You just take the length and you multiply it by the width. But inside of GIS, ArcGIS, we have tools that allow us to measure distances, and we're going to go out there and measure those distances in miles. So you just click on one end and you drag to the other end, and we can see that the length is about 123.1 miles. So somewhere students should be recording what you have, what kind of data you're gathering. So 123.1 miles is the length, and if instead you go down, you measure the width, you'll see that you have a width that looks to be, if you double click it, lets go of it. Looks like the width is 26.4 miles. So we would be able to get an approximation for what the area of that rectangle would be by multiplying the length that you calculated and the width that you calculated. And we would do that for all these different shapes. There's a square down here, and we find the area of a square by, again, length times width, or since it's a square and the length and width are the same, it's just the side of the square multiplied by itself. We've also added a triangle, and you can talk about how you find the area of a triangle. The formula is 1/2 the base times the height. And we even have put a trapezoid in, and you can see that the trapezoid, to find the area of a trapezoid, you average these two bases and you multiply that by the height. So we would slowly be able to fill up the surface area of this lake, and we could even make other shapes if you wanted to. And then this discussion gets into how you go through each one of those areas. And then, like, for the elaboration and extension on this activity, how could you be more accurate? We could put some other shapes that would fill in these spots that we're kind of missing in here. And there's even a tool. We turn all these layers off. There's a tool inside of ArcGIS that allows you to create the area. So if you go over here, you can find the area, and you can do it in square miles, and you could literally, start working your way around the shore and just keep clicking and being as accurate as you can, and you would eventually fill up the lake with shapes even more accurately. And at the end of it all, you could use that measurement and you can compare it all the way through. So and you could continue that, and you'd see that you could, at some point, the whole entire area of the lake would be filled in. And if you need to, you can kind of like move your map down so you can get the pieces that you're missing. I'm just going to keep going here just to give you an idea as to what the heck I'm talking about. But you can find the area of the lake pretty well. We're just going to keep filling in, avoiding islands, kind of avoiding the coastline. Double clicking at the end, 7,182.6 square miles, and a quick Google search showed that the area of the lake was, I want to say it's 7,340, and you could go through and do a little percent analysis to see how well your estimates compare to the ones that you were calculating.